Assalamu alaikum. Good morning, respected CEO sir and my distinguished colleagues. I'm honored to stand before you to share my insights on comparison between LRFD and ASD method for tension member design. I'm Rafiquql, structural engineer, DDS. Here's the short introduction. Structural engineering uses two primary methods for design. Number one is load and resistance factor design, LRFD, and the another one is allowable stress design. Both are used to ensure safety, reliability, and efficiency in tension members. Load and resistance factor design basis accounts for uncertainties in loads and material strengths. Uses factored loads and reduced resistance. The key formula for LRFD method is factored strength is greater than factored load. Here's the equation below. The phi Rn means nominal load, nominal strength must be greater than factored load, where phi is the resistance factor and gamma I is the load factor. Phi equal 0.9 for yield and 0.75 for fracture or shear. It focuses on ultimate strength design. Here's the LRFD load combinations in BNBC chapter part 6, chapter 2, section 2.7.3.1. Here's the basic combinations. Allowable stress design. Design basis uses a safety factor to limit stresses to allowable levels. It ensures stresses remain below material yield strength. The key formula is service load less than equal allowable strength. Q service means service load less than equal nominal load by safety factor. Here's the safety factor and Rn equal nominal strength. The safety factor for yielding is 1.61 and for shear is 2. It focuses on working stress design. Here's the ASD combinations. The relationship between resistance factor and safety factor. Here's the safety factor equal 1.5 by resistance factor. For reasons that we'll discuss later, this relationship will produce similar designs for LRFD and ASD under certain load combinations. When LRFD was introduced into the AISC specification in 1986, the load factors are determined in such a way as to give same results for LRFD and ASD when the loads consisted of dead and a light load equal to 3 times the dead load. Relationship continued. Let the nominal load Rn be the same for both LRFD and ASD when live load is equal to 3 times the dead load. Now we get Ru by ultimate load by resistance factor equal. When you consider the nominal load is equal for both methods, then we write the Ru by resistance factor equal to allowable load into safety factor. And it continues 1.2 dead load plus 1.6 live load by resistance factor for the LRFD and equal to dead and live load into safety factor for ASD method. Or 1.2 dead load plus 1.6 into 3 dead load in place of live load equal to D plus 3 dead load in place of live load. So we get 6 dead load by resistance factor and equal to 4 dead load into safety factor. So here's the relationship is proved. The safety factor is equal 1.5 by resistance factor. Now comparison between LRFD and ASD. The key points is load factors. LRFD uses different factors for various load types. ASD, single safety factor applied. Design philosophy. LRFD ensures ultimate load strength based design, and where ASD ensures the service load based design. Efficiency. LRFD more material efficient due to refined factors, and ASD simpler and easier to apply. Here's the graphical comparison of LRFD and with ASD for tension member. Is that visible? This phenomena is graphically presented in this graph. When the live load by dead load ratio is 3, then LRFD and ASD method give same design. When the live load by dead load ratio is less than 3, then LRFD method is more economical, and when live load by dead load ratio is greater than 3, it slightly economical in ASD design, but it's limited by 3% only. Comparison between LRFD and ASD continue. The design, here's the illustration of this graph as I mentioned before. Now I'm going to share an example calculation. The problem is dead load 200 kips, live load 350 kips. In LRFD method, from LRFD combination 2, the ultimate load is we found 800 kips. So ultimate load must be less than equal resistance factor into nominal load. So here's the calculation. We found nominal load is 888.89 kips. For ASD condition, service load is equal 550 kips, where allowable load must be less than nominal load by safety factor. So from here we get the nominal load is 918.5 kips. The required nominal strength is 918.5 kips, which means ASD is uneconomical than LRFD for this example. Now, advantages of LRFD. Number 1 is greater efficiency in material use. As I mentioned before, LRFD is more economical. Number 2, more accurate representation of load combinations. Number 3, provides a higher margin of safety for ultimate limit states. Advantages of ASD: simpler calculations and easier for hand calculations. Number 2, well suited for serviceability and elastic behavior. Number 3, preferred for a small scale or traditional projects. Here's a summary of this comparison. LRFD and ASD are complementary methods for tension member design. LRFD is more material, efficient and precise but complex. ASD is simpler and aligns with traditional design practices. Choice depends on project requirements and designer preference. Here's the references. AISD Steel Construction Manual and Structural Engineering textbooks, design examples for LRFD and ASD applications. Thank you.